Good evening, everyone. I hope you all can hear me and see the screen clearly visible to each one of you, I think. Yes, Shraddha, good evening. I hope I'm on. Yes, it's fine and perfect, right? Is there any issue with the audio? I hope I'm clearly visible to each one of you. The screen is absolutely fine. My voice is clearly audible. Yes, thank you so much. Only Shraddha in the class. No one else? So guys, there's a small error over here. That is the thumbnail suggests the classes because I just scheduled the class 2 days back at 7 p.m. That's why. Okay. That's why it came like 7. No issue. So this is a wonderful Telegram group. So small mistake here also. Today everything is mistake because seeing with 11th standard topic after a very long time. Yes, Shivani, good evening. So at BioPoint is our Telegram group link. Don't forget to like, share, and subscribe our wonderful YouTube channel of BioPoint. Stream the world of bio with your friends. Those who haven't yet liked the session, just click the like button right now and show your love and support towards us. Yes, give me hearts on the screen, then we can move with the supremely amazing second lecture of this, one of the most lengthiest chapter of human physiology. Not one of the most lengthiest chapter and the most important also. Yes. Give me hearts on the screen and let's move forward. Thank you so much. So today we are dealing with an absolutely new topic, that is generation and conduction of nerve impulse. Generation and conduction of nerve impulse is our topic of the day. So guys, please listen, very important one. There are mainly 3 steps of impulse transmission. Mainly there are 3 steps which are involved in the process of transmission of impulse. We know that the impulse transmission is an electrochemical method. So the first one is the maintenance of a membrane potential, resting membrane potential. There should be a potential difference so that only ions can flow from one region to another, which is one of the most important step which is involved in the process of conduction of nerve impulse. Second one, you have the action potential. There, after the potential, there should be a great difference over there, so that only flow of ions. And here, in case of skeletal system, we studied about calcium ions, right? In skeletal system, we during the muscle contraction we studied there about the calcium ions, but here we have 2 ions, that is based on the sodium and the potassium ions. Are those types of ions, are the 2 types of ions which is going to greatly helps it in the transmission of a nerve impulse. And the third one, it is the propagation after the action potential. After a suitable potential is generated, they have to be transmitted to other regions. So let's start with this amazing session. Give me thumbs up on the chat box before that. Yes, Rujana, good evening. Thank you so much. So let's begin with this amazing session on the topic generation and conduction of nerve impulse. So we have the first step, that is the maintenance of resting membrane potential. We have the resting membrane potential. So the neural membrane contains various selectively permeable ion channels. So the neural membrane, so the membrane of the neuron just has certain ions, certain channels for transport of ions. So in a resting neuron, what do you mean by a resting neuron? Resting neuron means no impulse. No impulse is being conducted by that particular neuron. Yes, it's mentioned here itself. Neuron not conducting any impulses is referred to as the resting neuron. So in a resting neuron, what you can see is that is in the normal neurons, you can see that, oh my god, yes, you can see that the axon membrane, guys, suppose this is the axon membrane, this red line I am marking is the axon membrane. Okay, axon membrane is more permeable to potassium ions and nearly they are impermeable to sodium ion. Guys, take out your NCRT, mark this sentence there itself right now. In the resting neuron, when the neuron is not conducting any impulses, when the neuron is not conducting any impulses, you can see that the axon membrane, that is the outer membrane of the axon, is permeable to potassium. That is the ion channels for potassium just increases. The ion channels for potassium are open, whereas no sodium exchange is going to happen over there. Clear? Clear? Clear everybody with this topic? What is the condition of the neuron when it is at rest? When it is at the resting membrane potential, that is, it is not carrying any kind of impulses, it is going to happen over there. That is, the axon membrane is more permeable to potassium, but it is nearly impermeable to sodium. And also, the membrane is impermeable to negatively charged protein also. Negatively charged proteins in the axoplasm. So the fluid, it is the axoplasm. It is, so inside this you have the axoplasm. The axoplasm just exactly similar to cytoplasm also. So that axoplasm is nearly impermeable to negative ions also. That is negatively charged protein also. Clear? Clear? Look guys, this is the condition when you can see the resting membrane. That is the channel for, this is a potassium conduction channel. Okay, the red that I am marking is a potassium conduction channel. So through that potassium ions can come outside or potassium ion can come inside. This is the outside region, this is the inside region. Clear? So potassium ion can be transported easily, whereas sodium, if it is at the outside, it will remain at outside only. Clear? Next. Therefore, concentration of K plus ions and negatively charged proteins in the axoplasm becomes very high. Right? Guys, actually we are telling here both, we know that both sodium and potassium are all positively charged ion, right? But when it comes into this case of the nerve impulse conduction, we consider sodium, since the number of sodium outside the membrane is higher, we would say that sodium is positive and the number of potassium we consider over here, it is sodium as a positive and potassium as a negative. Okay, if we can suppose, this might sometimes create a confusion in at least some of your minds. Guys, please check the sodium ions. The sodium ions are situated outside the axonal membrane. Am I right? Am I right? The sodium ions are situated outside the axonal membrane. Tell me yes or no on the chat box. On the chat box. Yes or no on the chat box. Nobody here? Am I audible? Am I audible? Am I audible? I'm not receiving any of your replies. Just 1 second, let me rejoin. No? Guys, am I audible to each one of you over here? No way, my god. Guys, please tell me yes or no on the chat box. I'm not receiving at least one of your comments. What's that? Yes, thank you so much. So guys, the sodium ion concentration outside the axon membrane is very high. But think only about sodium. Sodium outside the membrane, it is very high concentration of sodium. But when it comes to inside of the membrane, that is the axoplasm, the number of sodium atom is very less. Very less sodium atom, because at resting stage, the channels for potassium is only opened. That is why, since the number of sodium outside the membrane is very high, we would say that only positive ions outside. Only positive ions. So the outer side becomes positively charged, whereas the inner side, which contains potassium ions and no sodium ions, will become negative charge. Clear? If you are clear with this particular concept, give me hearts on the screen right now. How is the polarity happening? If you want me to repeat it once again, just comment me. So once again, I'll repeat it once again. Very happy for me to explain it once again. Yes, Shivani, the concept is clear for Shivani, Shraddha. Yes. Thank you so much. If you have any doubt, please ask me. And the concentration of sodium is low. So you can see that the axoplasm outside the axon contains a low concentration of sodium and outside membrane contains low concentration of potassium and a high concentration of sodium, right? So this creates, so positive, negative, so this creates a small amount of a potential difference in the neuron. So guys, this is actually the image. This is actually the image over here. That is, if this is the axon, the axoplasm becomes negatively charged because no sodium atoms are present. While as the outer, the extracellular matrix is all positively charged because sodium ions are present in a tremendous amount, right? So the ionic gradient is maintained by the active transport. What do you mean by active transport? What do you mean by active transport? Active transport means the transport takes place only if we provide energy. Only if we provide some amount of energy, active transport. We studied in digestive chapter digestion about active diffusion, passive diffusion. Passive diffusion means simply from one concentration to another it will flow, but active, from low concentration to high concentration, it will flow only with the help of energy in the form of ATP. We will study in detail about each terms, active transport, passive transport, everything in the plant physiology chapters. Okay. So guys, there is a sodium potassium pump. This is a sodium potassium pump. Okay. Guys, please respond. I think only 2 of you are here. So please respond to your maximum on the chat box. If you are feeling sleepy, then I'll be more sleepy than that. That's why I'm asking. Because this is one of the important chapter, but this chapter is not very good and not effective for one person to just make others understand. Whenever I am just in the full mood of taking this chapter, there will be no network, and I have to just keep on postponing this. This is how much time I just postponed this lecture. I think nearly 2 or 3 times. So guys, the sodium potassium pump is present. So it transports 3 sodium ions outside and 2 potassium ions into the cell. What is the function of sodium potassium pump? Sodium potassium pump. What is the function of sodium potassium pump? It transports 3 sodium ions outside and it pumps 2 potassium ions inside. As a result, the outer surface becomes positively charged. The outer surface becomes positively charged and the inner surface becomes negatively charged, and it becomes polarized. We studied about polar covalent molecules. one side will develop a slightly positive charge, other will develop a negative charge. Exactly like this, the top extracellular matrix develops a positive charge, whereas intracellular matrix develop a negative charge. So the electrical potential difference across the resting plasma membrane of the axon, you will call it as the resting potential. You will call it as the resting potential. So guys, this is how it becomes positive and negative. The potassium, sodium potassium pumps out 3 sodium molecules, so 3 sodium ions outwards and 2 potassium inwards. So the concentration of potassium ions inside the axon keeps on increasing, whereas the number of sodium ions outside the matrix keeps on increasing. So outer becomes positive, intracellular matrix becomes negative. Shraddha, Shivani, Srujana, is it clear for everyone? Can we move with the next slide? Your hearts on the screen right now. I hope nobody else is over here. Thank you so much. I hope Nila hasn't come yet from her college. I hope so. Okay, okay, Shraddha. Okay. Okay. So others, please listen. So next step, that is the action potential. Let me check how many are left. Yes, we have a bit. Okay, action potential. When a stimulus is applied, what is the stimulus at over here? What is the stimulus acting upon over here? The polarization difference. That is, one is positive, other is negative. So when a stimulus is applied, the membrane at the site A becomes permeable to sodium. This causes a rapid influx of sodium ions and reversal of the polarity. So guys, at this particular point, what happens when a stimulus, when there is the potential difference arises, what happens is that there is a rapid influx of the sodium ions towards the inside of the axon membrane. So what happens? Just look at the number of sodium ions only. Since sodium at the resting membrane stage, the sodium ions was high. The sodium ions was high inside the what? Sorry, the sodium ions number was very high outside the axon. So outside become positive, inner is negative. Please listen. Please listen. During the resting membrane stage, the outer has more sodium. So the outer membrane is greatly positive. Due to less availability of sodium inside, the inner membrane is negative. But when an action potential is created, at the second step, when the action potential is created, what happens? There is a rapid influx of sodium ions towards the inside of this membrane. So what is going to happen, guys? If we are using a bit common sense itself, we will understand that the number of sodium ions outside will decrease. The number of sodium ions inside the membrane will increase. So what happens? The outside membrane becomes negatively charged. Inner membrane becomes positively charged. Clear? Clear, everyone? So it causes a rapid influx of sodium ions and the reversal of the polarity. Outer side becomes negative, inner side becomes positive, and this condition you will call it as the depolarization. Very, very important. Depolarization. The electrical potential difference during depolarization across the plasma membrane, you will call it as the action potential and a nerve impulse. Guys, just imagine this. Just imagine this particular condition when you are when you are driving your car or when you are driving a bicycle right now. Okay, you are seeing suddenly a dog jumps to the road and you have to suddenly apply the brakes. Will it takes a lot of time for you when after seeing the dog also you will ride on the bicycle, and after 5 or 10 minutes then only the brake you are getting the information from the brain to apply the brakes? Is it so? Is it? Is this the way you are getting the impulses at this time? No, never. All these act generation, polarization, depolarization, repolarization, all these things are suddenly happening within a fraction of seconds. Everything is happening. Sodium ions, resting membrane potential, sodium ions rapidly influxing into the axon membrane. Finally, inner membrane becomes positive, outer becomes negative, and action potential is created. It has to be pumped from the spinal cord to all the motor muscles. It's going to be at a fraction of a second. Yes, Nila. I hope you were having your college classes till now. I just told others that you haven't reached your home. That's why you being late for the class. Yes? Yes. So at a fraction of a second, all these things are going to happen. Next, the third step, that is the action potential or the nerve impulse is generated. Have you all noted down this? Action potential, which is nerve impulse. No issues, Nila. I hope you will understand this because you have heard this. Yes. Propagation of action potential at the site ahead, site B, the outer surface is positive and the inner surface is negative. Guys, at a particular site only it is going to happen. Okay, at a particular site only sodium ions, the ions are going to get exchanged. So at this, suppose we are dividing it like this. In this area, what happens? The positive ions are inside and negative ions are outside. This is site A. At site B, what is going to happen? The potassium ions are inside only. So the inside is negative and the outside is positive. As a result, the current flows on the inner surface from site A to site B. So from site A to site B, a current flows. So on the outer side, that is from positive to negative. In the outer side, what happens? From site B to site A only, what happens? The current is going to get flow. So hence the polarity is reversed and action potential is generated at the site B. So guys, this is going to spread. First in site A, the same condition going to be repeated in site B. So when the condition occurs at site B, what happens? The site A will become polarized. Negative inside and positive outside. Right? The sequence is repeated along the axon and the impulse is conducted. The rise in permeability of the sodium is extremely short-lived. It is quickly followed by a rise in permeability to potassium. So whatever things are happening, the permeability of sodium is a bit low inside the axon. So even though it becomes reversed, the polarization becomes depolarized. When the nerve cells becomes depolarized, within a fraction of seconds itself, that is going to change to the back condition. Okay. So immediately potassium diffuses outside the membrane and restores the resting membrane. Thus the fibers become ready for conduction of a further stimulation. Clear? Clear? Yes. Next, this is a common term for you. Next, we are going to tell about or discuss about the conduction of nerve impulse at the synaptic membrane or the synaptic cleft. What is synapse? Synapse is a functional junction between two neurons. So guys, this would be the axon, not axon endings of one neuron. Okay, neurotransmitter acetylcholine present at the end. Okay, so you will have this. And below this axon terminal itself, you will have a generation of a new neuron. Okay, like this, another neuron is also going to get happen. So what happens is that the nerve impulse over here have to pass through from one neuron to the another. It is mainly of two types. There can be electrical synapse, there can be chemical synapse. There can be electrical synapse, there can be chemical synapse also. What do you mean by electrical synapse? In this, the membranes of the pre and the post. What do you mean by pre? Pre means before. Post means after. You might have studied about pre-fertilization events, post-fertilization events, right? So pre means the thing that is behind or before. That is the axon endings of the first neuron with the dendrite of the other neuron are in close proximity. So impulse transmission is similar to transmission along an axon. How an impulse is transmitted across the axon, that much easy will be because the two axon ending and the nerve what axon ending and the dendrite will be very close to each other. Without any gap, they will directly pass on to the next axon. So in this case, impulse is faster. So this kind of an impulse transmission, you will call it as electrical impulse when two adjacent neurons are very close to each other. So electrical impulses are very rare in the human system. It is all taking place with the help of the chemicals. What is the chemical? It is acetylcholine, which is a neurotransmitter. Acetylcholine, which is a neurotransmitter. Guys, today 9 p.m. you are having the Mega Botany Strategy. Fini 2021, 2022 also. Okay. Don't miss this session. Very useful. I'll be telling the weightage of the 19 chapters of botany over there in that section. Okay. Guys, can any one of you tell me how many chapters are there from our biology for our NEET exam? Can anybody tell me, give me a guess? I don't know how many of you just knows the correct value. Yes? Just give a guesswork. How many chapters enter biology for NEET syllabus? Just give I'll give you option 32, 36, 38, 40. How many? Anybody just give a guesswork. 32, 36, 38 or 40. How many bio chapters for both 11th and 12th altogether? No one? Oh my God. What happened, students? What happened? Yes. 38. We could say, okay, 38. Because we have 19 chapter purely zoology, 19 chapter purely botany. So from this 19 chapter, you will get 45 question. From this 19 chapter, you will get 45 question, total 90. I'll be telling the advanced all these things over weightage of each chapters of botany in the session which is going to commence at 9 p.m. today. Okay. A damaged joker, if you want to convey anything to me, can you please translate it in English? Okay. Thank you so much. So there is a fluid-filled space in case of synaptic cleft, you will call it as synaptic cleft, where you can see certain chemicals are released by the axon endings, that is the acetylcholine or the neurotransmitter, between the presynaptic neuron and the postsynaptic neuron. The presynaptic region have a swellings called synaptic knob or synaptic button. It contains a synaptic vesicle which is filled with neurotransmitter acetylcholine or adrenaline. Acetylcholine is most prominent, but you can see adrenaline also. Clear? Please take a screenshot for this. I hope Shraddha will do this after when she came back and watches the class. She will make the PDF and send this. I hope. Okay. So, chemical synapse is happening like this. Impulse reaches the axon terminal. The synaptic vesicle bind on the plasma membrane. It releases the neurotransmitter, diffuses across the synaptic cleft, combined with the receptors on the postsynaptic membrane, opening of the ion channels and generates the action potential. So the action potential may either be excitatory or inhibitory. The impulse may either be activatory or inhibitory. Okay. So that is all about today's class. Give me hearts on the screen and I'll give you a quick recap of the portion. Okay. Give me hearts on the screen. Yes. Thank you so much. Just all your eyes on the screen. You will have, oh my god. The audio will be low for this, but I hope this would be, you can clearly visible how a nerve impulse is getting transmitted. Okay, ready everyone? Just listen. I haven't taken the pen for writing, so if I take the video, will not. Yes, I hope it could be. No. Yes, just listen. So guys, this is a neuron. That is the axon. This is how the impulse is getting transmitted. Okay, from dendrites to the axon terminal, the impulse is getting transmitted. So a charge difference is always maintained for the conduction. Look, this is how outside membrane is positive, inner is negative. So the sodium potassium pump sends sodium ions outside, potassium ions inside in order to maintain a polarity. Okay. So guys, this is a resting membrane potential, positive outside, negative inside. This is how sodium channels are there, potassium channels are there, outside cell, inside cell. Guys, 1 second. Shivani, really sorry, because I don't know who the other person is. I think is not putting any kind of a right messages. I don't have time to talk to such people. But Shivani, really sorry, because by what by mistake I just made you timeout. Okay, the other person also I just reported. Okay, Shivani, by next class you can be able. Okay, I hope you are there. Yes. So guys, the sodium channels open and the sodium channels are sent towards inside of the cell. So only one portion is affected. Yes. So an action potential is created. So when action potential is created, there will be a rapid flow of sodium ions. Look how the sodium, after those are happening, the sodium channel gets closed. Look, the sodium ions are passing inward. After the necessary ions are passed, the sodium channels are closed. And then what happens? You see the potassium channels are really opened. So that is going to be getting shifted. Look, I'll show you once again. So guys, this is going to get shifted. Potassium outward, sodium inward. So potassium outward, sodium inward. So entire axon length, it is going to get differentiated. Clear? So thank you guys. See you in the next class. Not next class, today itself at 9 p.m. you will have the session Master Plan for Botany 2021-2022 NEET batch. See you there. Okay, bye bye. Prepare.